Today, I would like to introduce one of the innovation demonstration. Innovation title is left-handed metamaterial absorber for energy harvesting. My name is Dr. Mohammad Rashed Faruque. I am from University Kebangsaan, Malaysia. A perfect metamaterial absorber is a device in which all incident radiation is absorbed at the operating frequency. Energy harvesting is a process by which energy is derived from external sources. Energy harvesters provides a very small amount of power for low energy electronics, and the energy source for energy harvesters is present as ambient background and is free, as opposed to large scale energy generation which costs money. Energy can be stored in a capacitor for short-term use or battery for long-term use. Allows for the battery to be taken out of the equation of an application since it sources energy from the environment. Why use energy harvesting? Energy harvesting uses renewable source, allows for remote charging in applications. Before going to the innovations, we have to done some previous study, that means literature review. So Ju et al. 2011, they have to be designed as a metamaterial inspired antenna, and for the harvesting purpose, they have to be absorbed. The rectifying impedance is the 84.7%, and Hakis et al. Proposed a metamaterial where the maximum harvester power occurs 36.8% for 900 megahertz. Almoni et al. Presented a metamaterial that comprised of 13 by 13 square meter electrically small cells, which is the absorbed 97 and 93% absorptions. And Qui et al. Introduced an acoustic energy harvester based on a defected acoustic metamaterial with piezoelectric material. Their output voltage was using the 1.3 volt and was often 2.25 kilohertz. Why we have intention to do this product? Actually, some of the problem is still be there. Seems like that all of the product is bulky in size, costly fabrication process, and low efficiency and low bandwidth. In this invention, we have to develop 4 design methodology stage. One is the metamaterial absorber design and simulation. Another is the metamaterial characterizations. Another is the measurement of the absorption and composition, comparison the performance, and finally utilize the absorber the energy harvesting applications. For this design, we have to be use the commercially available software, which is based on the finite integration technique based. And that one we have to be used for investigate the S parameters. Unit cell boundary condition was used for the simulation. Nicholson-Rossiter boundary condition was used for the checking for the characteristics metamaterial. Measurement of a single unit cell was performed inside the waveguide and array between the horn antennas in the anechoic chamber. The metamaterial absorber will be then used for electromagnetic energy harvesting purpose. This is in our actually design, which we have to be built on in our innovation. This is the first in this slide. Look at this 3 picture. First one is the complete design of the unit cell. That one is the initial demonstrations of the unit cell, and last one is the unit cell with substrate. And under this table is total parameters of the built on the design. This the characterization of the metamaterial characterizations. That one we have to be done using the Nicholson-Rossiter method. And this is the measurements of the absorption. This is the important things because the proposed absorber shows 3 absorption peaks at 5.376 gigahertz, 10.32 gigahertz, and 12.25 gigahertz, with an absorption rate is 99.9%. Again 99.9%, and finally 99.7%. That means 3 frequencies absorption range is almost 100%. Then we have to be introduced in the how to absorb or use the energy harvesting. Look at this from this slide right side. That one is the use the in our signal generator transmitting the antenna, and transmitting signal, transmitting the signal, and this signal passes to the in our absorber, and finally absorber oscilloscope receive the signal. So that's why we can easily absorb the energy. Those energy is transmit to other places, and we can receive the signal due to the oscilloscope, and then we could do the summarize. The reason absorber can be used for energy harvesting by place to 2.3 kilo ohm resistive load in the splits where the absorbed power is inducted to the load. This is the prototype. Actually, we have in this figure, left side is the unit cell and that right side is the array. Why do the array? Because the metamaterials or metamaterial absorber or metasurface absorber cannot do the work as an individual unit cell. They have to do the periodically arrangement. So that's why we have to be built on this one is the as a array. This is the measurement and simulation stage for the three frequencies. Look at this, 3, 1, 2. Red color is the measurement and black color is the simulation. So the simulation and measurement result coincide to each other. So that's why we have to summarize that in our design is perfect. So that's why we come out the results. Result mentioned about that. We have to mention the three resonance frequencies. One of the 5.376, which is the covered the C band, and second one is the 10.32 resonance frequency, which is covered the X band, and the last one is the 12.25. That one is the cover is the Ku band. And if you think about that, this corresponding resonance frequencies versus absorption, first two. One is the 99.9%, almost 100%, and third one is the 99.7%. That one also nearly 100%. And if you go through the compare the simulation and measurement result, that one is the perfectly coincide to each other. So that's why the maximum output voltage and power across the 2.23 kilowatt kilo ohm gap resistor. That one actually we have to get this result from the energy harvester was recorded 1.2 volt and 0.26 milliwatt. In addition, the size of the single unit cell 10 by 10 millimeter square millimeter, that one is also compact size. As a result, the power density of the proposed harvester was 0.26 to 6 watt per kilometer, watt per cubic centimeter, square centimeter. Novelty actually wideband with left-handed from property-based metamaterial absorber, high absorption and low cost, exhibits fluctuation in sensitivity and wide angle of incidence, compact in size and effective ratio is 5.58, suitable for CX and Ku event. That means one design can cover the 3 events, and that one is the also high rate is the high absorption rate, almost 100%. And we are using the actually during the preparation is the materials is the small size, so that's why cost is the very low. So the maximum output voltage and power across the 2.3 kilo ohm gap resistor and was recorded 1.2 volt and 0.626 milliwatt. So this is the actually market potential. Actually, E-shaped absorber can be used to improve the efficiency of the solar panel. That means if we use the absorber as the border metal of the solar panel, then with the solar panel, the absorb itself absorb the electronic waves of our surrounding environment. Absorber as the border of the solar panel, the size of the panel can be reduced and efficiency should be higher. So another important applications is the microwave oven. Microwave oven, all of the microwave oven inside lower portion is the aluminum setup. So we have to be replace this aluminum setup to the metamaterial absorber. So at that time, we have to be consume the power and also radiation should be lower. So also size is the compact. So that's why if efficiency is the higher, so easily we can that means hot or anything say purpose we can do our jobs purpose easily use this one, and also radiation is too much low. So that one is the important factors for this. So last is actually a small double shape symmetry splitting resonators based absorber has a great impact for the picosatellite, because the picosatellite need to do sometimes power supply. So at that time, some small power supply can do that this absorber, metamaterial absorber. So that one is another important applications. So market strategy we have already done. So the product can be manufactured locally, financially viable, meet customer demand, product enrichment and with engineering support. Overall cost of the proposed product is around $65. At present, the market price is around $90 to $100. So summary, energy harvesting technologies are everywhere and efficiencies are vastly improving. Most of the world's energy in the future will be generated using power harvesting technologies. So this is some of the references, and thank you everybody.